Welcome to the Schroeder Academy. Today we're going to do a lesson on finding the arc measures of circles. Make sure you have downloaded and working on your EOC 7 and get that completed. You need your postulate and theorem sheet out whenever we do notes in Chapter 10. Alright, so for today, just a little vocabulary. We have done this before. We did this back when we were covering the area of regular polygons. We know that if an angle is inside of a circle, that it's called a central angle. So this is a central angle, and that angle and the arc that it hits, the angle is equal to the arc. All right, and we know that if it's a minor arcs are arcs that are less than 180, and major arcs are arcs that are greater than 180, and a semicircle is just equal to 180. Remember that major arcs, we name those with 3 letters, so major arc ADB goes here and all the way around. And that minor arc AB right here, which is less than 180, is just this part right here. A semicircle, remember, can use 2 or 3 letters. So here is the measure of a minor arc, is the measure of the central angle. So again, this is the arc is equal to the angle that it intersects. So in this case here, this is a 50-degree angle, and therefore the measure of that arc is 50 degrees. Remember that arcs are measured in degrees, but it's a different kind of degrees than angles. That's why we can have a 270-degree arc, but we cannot have a 270-degree angle because those are angular degrees, and they only go up to 180. All right, and so if we look here, remember that in a circle, the total circle is 360, and that remember in angles, we have here a straight angle, which you should remember is 180. And so then we have this angle is 110. So if we have 180 degrees, 180 minus the 110 gives us 70 degrees. So this is a 70-degree angle here, and this is a 180-degree angle here. So it asks for us for the measure of arc RS. So it's from here to here. So RS would be equal to 110 degrees, just like the angle that intersects it, and it is a minor arc. B asks us for RTS. So for part B here, RTS. Follow it around the circle. It's like a little path. RTS is here. So we can do that by taking the 360 and subtracting the 110 to see what's left. And when I do that, I get that it is equal to 250 degrees. It's also greater than 180, so it's a major arc. And finally, C says arc RST. So RST is from here to here. That's a C in blue. And we know that that's a semicircle, so therefore it's equal to 180 degrees. And that is a semicircle, like we said. Okay, so this was just a little practice. Remember that inside of a circle, know that vertical angles are congruent, know that you have straight angles, you have obtuse angles, right angles. All those things are still working from the very beginning of the year when we first learned them. All right. Postulate 23, which is a postulate, it's not in the theorem section, the postulate section. It just says that if you add 2 smaller arcs, you get a larger arc. So that means you can add the measure of one arc here plus the other arc here, and that equals the whole entire arc altogether. It's not necessarily, you'd kind of know this information already, just that you can add things, but it's just good to put it into postulates so that you can just have it as a statement. Adjacent arcs, which it says up here, says adjacent arcs are just 2 arcs on a circle, and they're adjacent if they have a common endpoint. So in this case here, A is the common endpoint for the 2 arcs. They just really want to make sure you understand your vocabulary. All right, so take a minute, draw out this circle, and I want you to pause the video and do all 6 of these and see if you can answer all these correctly. Remember to state whether they're a minor arc or a major arc and find their measure. Okay, so now that you've done those, let's just show you the answers to each one so that you can check them and see how you did. Remember that if you didn't get one right, you might want to leave that answer alone, bring it back to class, or write a question next to it, say why wasn't this one this value, so that we can talk about it when you come to class and maybe explain things a little bit better for you so that you can understand them. All right, next, congruent circles and arcs. So 2 circles are congruent circles if they have the same radius And two arcs are congruent arcs if they have the same measure and they are arcs of the same circle or congruent circles. So what it says here is it says if I have this circle here, we'll just call this circle A, and I've got circle B here, and I tell you that they both have congruent radiuses. Number one, wouldn't their areas be the same if the radius is the same? So that means that whatever this arc is here, arc AB and arc CD here, that arc AB's measure is equal to the measure of arc CD because the circles are congruent and these angles will be congruent. As long as those angles are congruent, those arcs will have to be congruent. Again, we're just doing some foundation work here so that you can apply all this information when we start doing problems. So that's kind of the end of the information that we had to work with in 10.2. You're just going to be basically working with central angles and intercepted arcs and just adding and subtracting a lot around 360. Next, I'm going to go over 3 homework problems that may have been difficult for you so that if you had some problems on those, you can go back and look at this work being worked out for you. This is one of the homework problems that people tend to have an issue on. All right, so if this value is an x, we know this value is also x because these two pieces have to be congruent because they are tangents from an external point. We know that these two pieces here and here have to be congruent and that these pieces here have to be congruent. The problem is that we don't know how to divide the 18 up. So what you have to do is you have to put more radius into this circle here. They're all the same. And if this is a 90 degree, that this is a 90 degree. And so therefore we have a square going on here. All right, and once we have that square, we know this is 5, so we can now make this as 13, and we can make this one 13. And now we have all the sides of this. What people don't see when they're working this problem is they miss this right angle right here. And that right angle makes this whole entire blue triangle a right triangle. And so we can use our Pythagorean theorem, or a squared plus b squared is equal to c squared. And so when I put that information in there, this whole side's my hypotenuse. So this is my hypotenuse, which is equal to my c. We'll call this my a side. We'll call this my b side. So our a side is x plus 5 quantity squared plus 18 squared equals x plus 13 quantity squared. If you could not get this far, then you might want to pause the video and see if you can work the rest of this out and see if you can get the right answer now. Or if you can't work from here, or after you try it you mess up and you're having difficulty, I'm going to finish working this problem now. All right, so once we have it to this point, we have to FOIL out that information. And what happens is a lot of you guys forget to write this twice and FOIL out. 18 squared, which you can do, that's 324, and then x plus 13 times x plus 13, because many of you are still trying to just square the two numbers in there, and that does not come out right. So we have x squared plus 10x plus 25. Oh, that didn't really turn out right. Okay, so plus 25 plus 324 equals x squared plus 26x plus 169. Well, there's an x squared on both sides. Since there is, you know, they will cancel when we move to one side. And so then I have 10x plus 349 equals 26x plus 169. I want to get the values be positive, so let's just subtract 10x here and 10x here, and minus 169 here and 169 here. And so we get 16x equals 180. Therefore, x is equal to 11.25, which is what this problem was asked for, is find the value of x. All right, so I think the biggest mistakes that are made, the most common that are made all the time, would probably be right here and here, where we do not multiply those out correctly. So be careful of those places in the problems. All right, so that was one of the homework problems that people tend to have issue. Another one that people have issue is this one, because they don't know what to do with the picture, and they have problems working with this picture here. So here's what I'll tell you to do. We only learned one topic, and that was that it's all about tangent lines. So this segment right here is tangent with this segment right here. So we know there's a right angle here. And so this is a radius, and we know this is a radius also. So we have to put those in there. They're not given in your picture. So you got to work through those. Now, once we have that, it tells us that we need to find the volume of this tank. And so the tank's 10 feet tall. So then we take and we got to solve for this value. So we have r squared plus 26 squared equals r plus 14 squared. And there was a problem just like this setup here in your notes from yesterday. So r squared plus 26 squared is 676 equals r squared plus 28r plus 196. Subtract, we get 480. Remember, the r squareds here are going to cancel, so it's not really a quadratic. Don't get scared because you see an r squared every time. We divide by 28, divide by 28. So I get 120 over 7 is equal to my radius. Now, this is a cylindrical water tank, so volume is equal to pi r squared h. Oops, h. So pi, my radius is 120 over 7 squared times my height, which we said was 10. When I put all that in there, I get 1,400. Well, I get 14,400 pi over 49, which is approximately 932.436 feet cubed. So, of course, you can go right here for your exact answer. You can get, this is our exact answer, and this is our approximate rounded answer, and we multiply out by pi. All right. And our last one that we have is this one. And you know what? If you did not write the paragraph proof, I'm not too worried about that. I'm not going to make you do paragraph proofs. But you kind of have to think about what's going on in the problem to be able to work the problem. So they gave you the hint there by telling you that QRST is a rectangle. So if that's a rectangle, and they told us QR is 2, so this is 2, which means that would have to be 2. They tell us that PS from here to here is 8. That's important. PQ is 12, so from here to here is 12. Well, that's all the given information out of us, but they ask us to find, let's do that in green, RS, which is here. That's unknown, and they ask us to find angle P, which is unknown. All right. So if we look, if this is 8, doesn't that make that 6 when we subtract 2 from 8? That's back to the segment addition postulate we did the very first few weeks of school. And so we know that this is 12. Well, what kind of triangle do we have that's a right triangle? Let's look at this separately. A right triangle, we have 6 and we have 12, where the hypotenuse is twice the side there. And if you think back, that's a 30, 60, 90. So this is a 30, a 60, and a 90, which makes this piece 6 squared root of 3. Well, that's the QT here, which is 6 squared root of 3. If it's a rectangle, that's 6 squared root of 3. So we just figured out that question, which is 6 squared root of 3 inches. And again, back here, we put that in there. This is the angle that I wanted to know. It's a 60-degree angle. So remember, look for those little clues on there sometimes. You know, the hypotenuse was double the leg. And so those are probably 3 of the tougher problems on the homework. Okay, good luck doing the other pages. The pages are listed in your calendar. What you want to work on is anything that says 10.2. So 10.2 homework pages. I will make sure they're listed on the website just in case you don't know which pages those are.